Exercise 4.5, question number 25. We need to integrate this function, that is 1 over 2x square minus 3x plus 1 under root 3x square minus 2x plus 1. Consider this function, that is 1 over 2x square minus 3x plus 1. Just factorize this function. That is 1 over, you will get here after factorization, x minus 1 into 2x minus 1. Now find the partial fraction of this function. That is, let's a over 2x minus 1. I'm just partial fractioning it. A over 2x minus 1 plus b over x minus 1. After using the partial fraction method here, I will get the value of a as minus 2 and the value of b as 1. Use these values here, we will get minus 2 over 2x minus 1 plus 1 over x minus 1. I just split this fraction into the two fractions using the partial fraction method here. I have used here the partial fraction method. Now, what was our main function? Just write that function, that is 1 over 2x square minus 3x plus 1 into under root 3x square minus 2x plus 1. That will be equals to minus 2 over 2x minus 1 plus 1 over x minus 1 multiply by 1 over this denominator, that is 3x square minus 2x plus 1. Now multiply this denominator with this fraction and with this fraction. It will break into minus 2 over 2x minus 1 into under root 3x square minus 2x plus 1. And then plus 1 over x minus 1 into under root 3x square minus 2x plus 1 here. Now just write the functions in the integration. We will get here integration of 1 over 2x square minus 3x plus 1 into under root 3x square minus 2x plus 1 dx. That will be equals to minus 2 integration of 1 over 2x minus 1 into under root 3x square minus 2x plus 1 dx, and this second integral plus integration 1 over x minus 1 into under root 3x square minus 2x plus 1 dx. This one. Now name these integrals. Let's suppose the main question is the I. This is equals to this integral is I1 and the second integral is I2. Now I am separately solving these integrals. Consider the I1. I1 is equals to minus 2 dx over 2x minus 1 into under root 3x square minus 2x plus 1. This function. Now we need here some substitution. Let that substitution, the linear function, that is 2x minus 1 is equals to 1 over t. Then we'll get 2x is equals to 1 over t plus 1. So x is equals to, x will be equals to 1 over 2t plus 1 by 2. Dx will be equals to minus 1 over t square and this 2 constant dt. Now here use these substitutions. We will get I1 equals to minus 2. Dx has minus 1 over 2t square dt divided by 2x minus 1 is 1 over t under root 3 into x square. X is 1 over 2t plus 1 over 2 whole square. Then minus 2 into x, 1 over 2t plus 1 over 2 and the ending one, this plus 1. This 2 and this 2 be cancelled. Negative will become positive. 1 over t will be cancelled with this 1 over t. So I will be left behind with I1 equals to integration 1 over t dt divided by, now the denominator will be solved and I will get here under root this denominator. This one is 3 into 1 over 4 t square plus 1 over 4 and 2 times 1 over 2t into 1 over 2. This will give us 1 over 2t here minus 1 over t minus 1 here. because this 2 is multiplied inside, will cancel, and the rest of the signs will be written here, plus 1 dt. This 1 and 1 can be cancelled out. So we'll get here I1 equals to integral 1 over t dt over under root. Here we will get 3 over 4 t square plus 3 over 4 plus 3 over 2t minus 1 over 2t here. Now I am taking 1 over t square common out of it. When 1 over t square will be common out of this under root, it will come outside like 1 over t. So inside we will be left with, I have taken here 1 over t square common. I will be left with 3 over 4 plus 3 over 4 t square plus 3t over 2, and here I will get minus t like this. This 1 over t and this 1 over t can be cancelled out. So I1 will be left behind dt over. Solve the similar terms. These two are the similar terms. In the under root, I will get here 3 by 4 t square and 1 by 2t, this one, and plus 3 over 4. Now make the coefficient of t square as 1. Take that 3 by 4 common. I will be left with I1 is equals to integration dt over under root 3 over 2 outside, and this square root will be left behind with t square plus 2 over 3t plus 1. Now this will be moved outside, so I1 will be equals to 2 over under root 3 integration dt. By using the completing square method here, I will get inside my square root t plus 1 over 3 whole square plus this one. Here I will get 2 under root 2 over 3 whole square. Now this is the formula for integration of 1 over x square plus a square under root. Has the formula sine hyperbolic inverse x over a. So it will be integrated by I1 is equals to 2 over under root 3 sine hyperbolic inverse t plus 1 over 3 over 2 under root 2 over 3 plus constant of integration. Now replace back the value of t. What is the value of t here? I can take the value of t from here, that is t is equals to 1 over 2x minus 1. Put the value of t here. After using the value of t here and after simplification, we will get 2 over 3 sine hyperbolic inverse x plus 1 over under root 2 into 2x minus 1 here. This is basically after using the value of t. The value of t is 1 over 2x minus 1. Use the value of t here, simplify, we will get this answer here, plus constant of integration. Now only our first integral is solved, but we are left with our second integral. Consider the second integral now. That was I2 is equals to integration of 1 over x minus 1 under root 3x square minus 2x plus 1 dx. For the second integral, now we need again the substitution. That is, let x minus 1 is equals to 1 over t. So x is equals to 1 over t plus 1. So dx is equals to minus 1 over t square dt. Substitute back the values here in this integral. I2 will be equals to integration minus 1 over t square dt over x minus 1 is 1 over t, and inside this integral 3 into this, that is x square, that is 1 over t plus 1 whole square, minus 2 into x is t 1 over t plus 1, this is 1 over t. 1 over t plus 1 and plus 1 here dt here. Now this 1 over t will cancel with this 1 over t, and I will be left with I2 equals, after simplification I will get here dt over under root 2t square plus 4t plus 3. Now make the coefficient of t square 1, take this 2 outside. So I2 will be equals to 1 over under root 2 dt over under root, this will become t square plus 2t plus 3 over 2. Now use the completing square method here, that is repeatedly discussed in the previous parts as well. So I am directly writing the conversion form after completing square. Here in my under root, I will be left with t plus 1 whole square plus 1 over under root 2 whole square. This is the same formula for the sine hyperbolic inverse. So I will get I is equals to 1 over under root 2 sine hyperbolic inverse x. X here is t plus 1 divided by this a, that is 1 over under root 2 plus c. Use the value of t here. What is the value of t? T is equals to 1 over x minus 1. Use the value of t here. I will get I2 will be equals to, here I will get minus 1 over under root 2. This negative sign is also here. Minus 1 over under root 2 sine hyperbolic inverse under root 2x over x minus 1 plus constant of integration. Now you got the answer for I2. You also got the answer for I1. Substitute back all these values in this main integral. That is I is equals to minus 2 I1 plus I2. So the answer will be, using values of I1 and I2, we will get I is equals to, my I was equals to minus 2 I1. So it is minus 2 into 2 over under root 3 sine hyperbolic inverse x plus 1 over under root 2 2x minus 1, and plus I2 is minus 1 over under root 2 sine hyperbolic inverse under root 2x over x minus 1 plus constant of integration. So after simplification, I will get here, this is minus 4 over under root 3 sine hyperbolic inverse x plus 1 over under root 2 2x minus 1. There here I will get minus 1 over under root 2 sine hyperbolic inverse under root 2x over x minus 1 plus constant of integration. Question number 26 is, we need to integrate under root x over 1 plus 3 under root x. This is basically x raised to power 1 over 2 divided by 1 plus x raised to power 1 over 3 dx. We need to integrate it. Here we have one of the power as x raised to power 1 over 2 and the other power is x raised to power 1 over 3. So let's have a substitution here. Let x raised to power 1 over 6 equals to t. Then the derivative will become, here we can also write it like x is equals to t raised to power 6, taking 6th power on both sides. So we will be left with dx is equals to 6t5 dt here. So let's just substitute it here. We will get, this one will be equals to, now we have here x raised to power 1 by 2 dx. X raised to power 1 by 2. We need here, we have here x is equals to t raised to power 6. I need here x raised to power 1 by 2. So taking 1 by 2 power on both sides. So I will be left with x raised to power 1 by 2 is equals to, this thing will become t cube. So write here t cube. And in place of dx write 6t5 dt divided by 1 plus x raised to power 1 by 3. X raised to power 1 by 3 will give me t raised to power 2. That is t square. So it will become, 6 will be taken outside, integration t raised to power 8 dt over 1 plus t square. Now you see the numerator is greater than denominator. So just divide it because it is an improper fraction. Write the denominator outside and write the numerator inside. Now t8, you have to divide this 1 plus t square with t8. Write t8 divided by t square. You will get here t raised to power 6. So it will be t raised to power 6 and multiply it now. You will get t raised to power 8 plus t raised to power 6. Subtract it. Now minus t raised to power 6. Now again divide this negative t raised to power 6 with t square. You will get here negative t raised to power 4. Now again multiply it with both the terms. You will get here negative t6, negative t4. Subtract it. You will get t4. Now divide again t4 with t square. You will get plus t square. Write it here. So now multiply again it with both the terms. You will get t4 plus t square. Subtract it. You will get negative t square. Again divide it. If you divide it, you will get minus 1. Multiply minus 1 with both of them. You will get here minus t square minus 1. Subtract it, you will get here plus. Now you need to write, I cannot divide it further. So you need to write it in fraction form. How you are going to write it in fraction form? First of all, you will write this thing. That is t raised to power 6 minus t raised to power 4 plus t square minus 1. Then plus 1 divided by this one divided by with this term. 1 plus t square, and this thing is dt. Now you can easily integrate it. You know how to integrate it. T raised to power 6 will give you t raised to power 7 over 7 minus t raised to power 5 over 5 plus t cube over t minus t. And this integration will give you tangent inverse of t plus constant of integration. Now substitute back the value of t. You know that t is equals to x raised to power 1 over 6. So it will become 6 into t raised to power 7. It will be 7 over 6. So it became x raised to power 7 over 6 over 7 minus x raised to power 5 over 6 over 5 plus x raised to power 1 over x raised to power 3 over 2 over 3 minus x raised to power 1 over 6 plus tangent inverse x raised to power 1 over 6 plus constant of integration. So this is a solution for your question number 26. Now move on, question number 27. That is x cube over under root 1 plus x square. Now here substitute x is equals to tangent of theta. So dx will be equals to secant square of theta d theta. So it will be integration of x cube over under root 1 plus x square dx. That will be equals to under root integration x cube will be tangent cube of theta, and dx is secant square of theta d theta divided by 1 plus x square is 1 plus tangent square of theta under root. So this will be equals to integration tangent cube of theta secant square of theta over 1 plus tangent square of theta will be secant square of theta, and under root secant square of theta will give you secant of theta d theta. This one will be cancelled. So you will be left with integration tangent cube of theta secant of theta d theta. It can be written as integration tangent square of theta, and I am breaking this tangent cube of theta into two parts. Tangent square of theta, tangent theta, secant theta d theta. Now here I can use integration by parts formula. I am separating the both functions. Let it to be the first function and this one as the second function. So integration by parts will give us first function into integration of second function is secant theta minus integral derivative of first function is 2 tangent theta and derivative tangent theta is secant square of theta. 2 tangent theta secant square of theta, and this secant theta it will come as it is d theta. First function into integration of second function minus integral derivative of first function into integration of second function. So it will become tangent square of theta secant theta, and this one minus 2 will come outside and it will be left with tangent theta secant theta into secant square of theta d theta. Now you see the derivative of secant theta is present here. The derivative of secant theta is tangent theta secant theta. So we can easily integrate it. The power plus 1 divided by that power plus constant of integration. So I will get here tangent square of theta secant theta minus 2 over 3 secant cube of theta plus c. Now I need the value of theta here. What is my theta here? My theta is tangent inverse of x. What I let in the start x is equals to tangent of theta. So from here I can get the value of tangent square of theta, but I don't have the value of secant theta. You know that 1 plus tangent square of theta is equals to secant square of theta. This means secant theta is equals to under root 1 plus tangent square of theta, that is under root 1 plus x square. Substitute the values here. We will get tangent square of theta will be x square and secant theta is 1 plus x square minus 2 over 3. Secant cube of theta will be 1 plus x square raised to power 3 by 2 plus constant of integration here. Now, last question of this exercise is question number 28. That is 1 over under root x plus 2x raised to power 1 over 3. Now here you see we have one of the power as x1 by 2 and the other power is x1 by 3. Let's have some substitution as the similar to the question number 26. Let x raised to power 1 over 6 is equals to t. So it will be equals to x is equals to t raised to power 6. So dx is equals to 6t5 dt. So we will get here, just substitute the values. Integration 1 over under root x plus 2x raised to power 1 over 3 dx. That will be equals to integration dx is 6t5 dt divided by x raised to power 1 over 2 will give us t cube plus 2x raised to power 1 over 3 will give us 2t square. Now I can take t square common out of it. I will get 6t5 dt over t square common. I will get here t plus 1, t plus 2. This can be cancelled. So I will left here with 6 can be taken outside, t cube over t plus 2 dt. Again I will just divide these terms. After dividing I will get here t square minus 2t plus 4 minus 8 over t plus 2 dt. Just divide it, and that division method is also explained to you in question number 26. Now integrated, this will become 6t cube over 3 minus 2t square over 2 plus 4t minus 8 ln of t plus 2 plus constant of integration. And now substitute back the values of t. What you left in the start, you left x raised to power 1 over 6 is equals to t. Now use the values of t here. You will get here 6. This one will give you x raised to power 1 over 2 minus 6 x raised to power, just multiply 6 inside and do it in one step. I will get here 2x raised to power 1 by 2 minus 6x raised to power 1 over 3 plus 24x raised to power 1 over 6 minus 48 ln x raised to power 1 over 6 plus 2 plus constant of integration. I hope you understand well this exercise 4.2. For more videos, keep